Okay, so what I want to do now is I want to extend the transportation model to another model called the transshipment model. Okay, this is an extension of the transportation model. The only difference is this, and I'm going to use this to indicate you. Okay, so once again, you will have some kind of node. Okay, so you have some kind of supply nodes. You have some kind of supply nodes. And these ones have to send certain things to these areas, before these areas will now carry them to another area. Okay, that's how it is. It doesn't always have to be this number. So you can even have 4 of this. Now, or you can even have 3 of this here. So these gaps here, and it's very important you appreciate this. Oh. So you are sending it from this demand to this, okay? You're sending it from this demand to that. You're sending it from this demand to that. These guys are called the transshipment guys, okay? Because they get it, but they also have to transfer it, okay, to those very sources that they have to transfer it to. They just send it there. You just send it to each one. So once this guy gets it, he's supposed to distribute it across. And once this guy also gets, he's supposed to distribute it across. So you can see that the thing about the transshipment guys is that they don't keep the thing. They don't keep it. So eventually, if you have a number here, and this point is very, very important just before we continue. If you have a number here, which was maybe 150, you have a number here, which was 350, okay? And those items get into these transshipment guys, eventually they don't keep it. So the item go here, maybe here he was demanding 50, here was demanding 150, here was demanding, okay, or something like that. But eventually the transshipment guy don't get it. So when you are calculating the decision variables for the transshipment, the same approach, you are looking for the acts that are entering into it, okay, which will be receiving one, the minuses. And then you also be looking at, so you look at acts that are entering into it, and then you look at the acts that are leaving it. So the transshipment guys will now be looking at, let's say this one is 1 3, okay? Let's say that this is 1 3. So you're going to look at 1 3, entering into it, and then 3 7. So x3 7, leaving it. So you're going to have something like minus x13 plus, what is it? Plus x13 minus x37, something like that. You're going to see examples of that. So the transshipment don't have anything on the right-hand side. Eventually, whatever is on the right-hand side becomes 0 for the transshipment nodes. Okay, so keep that in mind. Okay? Keep that in mind whilst we now go through this. All right, so the items may be transported from a source to a destination, one source to another, one transshipment. And this is a typical example of a transshipment confusion. That's what I call it, transshipment confusion. So if you look at this, okay, a transshipment is receiving and is sending, a supply is sending, a supply is sending, a supply is sending. You can supply from a supply to a supply, okay? But you can demand from a demand, from some transshipment to a transshipment, but demand you demand, okay, but kind of supply and all of that, things like that. Okay, so that's it. But the key point is the transshipment guys. They are always in the middle. They don't keep. Whatever they keep, they also send it out. So we're going to go back to our wheat story and then race structure. Remember, the wheat originally were from 3 grain elevators, Kansas City, Omaha, and then DM. They were from these 3 grain elevators, and they were sent to the mills. Do you remember? The mills in Chicago, the mills in Cincinnati, the mills in St. Louis, and all of that. They were sent to those mills. But now we are going to now tell you where it was harvested from, so that you will now see the transshipment. So what is going to happen is that there are farms in Nebraska and Colorado, and these farms, they were the ones that harvest before they are transported to the grain elevators that we mentioned in Kansas City. But we didn't talk about those in Nebraska and Colorado. Now we are telling you that the grain elevators were not supply as we thought. They were actually transshipment nodes because the actual supply were the Nebraska and Colorado. That's what this one is saying. And the transportation cost from the Nebraska and the Colorado to those, those Kansas City, Omaha, Demo, these costs are the ones that you are seeing right here. So we are just adding this one to the original. So how would you have formulated it? What it means is that we are going to have Nebraska, Colorado first. Then we have Kansas City, Omaha, Demo second. Then we have Chicago, St. Louis, and Cincinnati third. Do you get it? So you're going to have something like this. Of course, it kind of matches exactly what I just said. So you're going to have something like Nebraska and Colorado, okay? And then that is going to take us to Kansas City, Omaha, and DM. And then we'll have Chicago, St. Louis, and then Cincinnati. Okay. So if this one is 1, 2, 3, 4, 5, 6, 7, 8, these guys in the middle, they are going to form the transshipment node. So you're going to have this arrow pointing towards 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 this, okay, this arrow pointing towards this, okay. Then we have from here, going to that one there, going to that one there, going to that one there. Then from here, going to this, going to this, going to that, and then from here, going to this, and then going to that. So we're going to have that as our, our gap. And then, of course, you're going to write the names and the costs associated with each one of them. This is something that you guys know how to do. So I'm just going to show you. Okay. So those are the original costs that we had already. They've not changed. Okay. Now, how do you define the decision variable for this transportation model? It's a transportation model, but it's a transshipment model. A transshipment model is more or less a transportation model with a kind of an intermediary. Okay. Develop the model and then formulate the mathematical model. So the same thing. This is what you're going to get. What I just drew. Okay. So you're going to get this. And you see that now the Nebraska and the Colorado, they have these items. Okay. You have these items there. And then these items will go to 3, 4, 5. And then they will send it to 6, 7, 8. So what it simply means is that the decision variables are going to be a lot. Do you realize that? It's going to be a lot. Okay. The way you define these ones, they have not changed. Let X1 be the amount of wheat transported from node I to J. The same thing as before. And then if it is from node I to J, where I is not equal to J. Okay. So in this case, you just write I is from blah, 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 1 to. Okay. So in this case, the I will be from 1 to 5. Okay. And the J will be from 6 to 7. So once you've done that, you get something like this network model. Now, if you look at this, I've removed the decision variables from it. So the thing looks beautiful than this. This one looks very complex, but it's okay. We know where we came from, right? And then you can now do your Zmax. When you're doing your Zmax, the same thing. You just pick in the number 16, blah, blah, 15, blah, blah, 10, blah, blah, 14, blah, blah. Okay, so you're picking the numbers, okay? Picking the numbers from here, picking the numbers from here, picking the numbers from here, multiplying it by the decision variables, multiplying it by the decision variable. And then you keep going like that, and then eventually you're able to get your objective. So you see that I told you that the decision variables are going to be plenty, the cost is going to be plenty, objective function is going to be longer because now we have more acts. Subject to the constraint. The constraints are going to be the same as before. The only thing I want to talk about is the transshipment constraint. So look at the transshipment constraint. Look at this very well. Now, if you look at this, you can see that it is looking at the acts that are coming to it, which are positive, and the acts that are leaving it. Okay, normally these ones that are leaving it are the ones that are here. Okay, so when you come here, okay, so the acts that are coming to it, if you look at this X13 is coming into it, coming into the 3. It is entering the 3. Okay, and if you 3, it's also entering the 3. So they are the plus. Then which are the ones leaving the 3? That one here will be leaving the 3. Okay, this one here will be leaving the 3. And that one there, X38, will be leaving the 3. So they will be minuses, and that's why you see them as minuses right here. And I told you that at the end of the day, on the right-hand side, there will be nothing because some are leaving it. So the formulation is basically the same. In fact, the top one up there is the same as that we did before. The only thing is that now they are from Nebraska and Colorado, and you just have to do with them. The only slight tricky part here is the transshipment part. Look at the acts that are entering. These two acts are entering, okay? And then look at the acts that are leaving. The acts that are leaving are minuses. The acts that are entering are plus. That's all. It is a minus because it's leaving it. When something is leaving an act, it's a minus. When it is entering another act, then that act will see it as. And if you look at the constraint, there are 8 constraints. So obviously there are 8 nodes. Okay, so that is it. And now, of course, you don't forget your non-negativity constraint. And then you are good to go. I didn't want to pay too much attention to this, but you just have to know, okay? So that is it. That is how it's supposed to be. You can work this thing in Excel, which I've done it already for you. Look at it and then familiarize yourself with it. And then I indicate here that your mathematical model was solved. Part of it is shown here. Part of it is shown here. So the question, my interest is your ability to use this part of it to solve your final situation. So use it. Okay, you have been told to use it to answer the questions that follow. So the first question was, what formula was typed in cell I11? Now, when you go up here, what is that? If you look at this, okay, formula I11. So this is I, okay, and that is 11 there. Okay, so he's asking that what formula was typed in formula I11. Now, it's a total cost formula. And the total cost formula, if you have done the formulation, you will know that it's a whole of this. So look at it. It's 16 multiplied by x13, 10 multiplied by x14. So I need to know where the 16 is, where the 10 is, where the 12 is. Now, let's go back to the answer. Okay, so when you look at this, where is the 16? This is a 16. This is a 10. Okay, this is a and the 12. Okay, so those are the objective coefficient, the cost objective coefficient. Okay, now so when you look at it, they are in the F column. Okay, they are in the F column. So this one will be F2. Okay, the 16 will be F2, then F3. Now, what would they be multiplying? They'll be multiplying the x's. Let's go back to the objective function. They'll be multiplying the x's, the x13, the x14, the x15. They'll be multiplying these x's. Where are they in the answer? So this is a way for you to look at the answer. But look at the sum situation here. It says that from ship from. Okay, so you are shipping from here to there. You are shipping from Nebraska to Kansas City. That's where you're shipping from. From Nebraska to Kansas City. So the question now we need to note is that where are our solutions? Where are our solution variables? Okay. What did you ship? What did you ship? Because once you know what you ship, that's important. Now, if you look at the net flow here, these were the items that we had from Nebraska. okay, to those ones. Okay, and then these were the items. You remember the Kansas City guys? I told you that the transshipment nodes, they are no longer going to have the values. They will have zeros in the end, and those are the for those ones on there. So these ones that you are seeing here are like the right-hand side of the constraint. So where are the items that were truly shipped? Where are they? That's it. This section here. That's it. So these are the items that have to be connected to what is here to be able to find your objective in this section of the cost. So how would we have done the multiplication? Well, normally one way one can do is I take the 16 multiplied by 0, take the 10 multiplied by 0, take the 12 multiplied by 100, and then blah, 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 blah. Okay, but that's good. That's a way to look at it. But what is another way one can look at it? Okay, let me just delete this first. So this is it. Okay, it says that it is going to be A2 to 16 and then F2 to 16. I'm using sum product here. Now, sum product is a formula for X. Excel uses it. But another way you could have done this is you take, but that's going to be longer. So the key point you are trying to do is that you are saying that multiply the items from F2, all right, this is the 16, F2 by the item in, what do you call it, A2. Multiply that from F2 to A2 and then sum them. So you multiply each one. Okay, so 16 times 0 plus, that's a sum, 10 times 0 plus. So you use a formula in Excel called sum product. So sum product will mean that drag all of this from F2 to F16. And I'm using the 16 here. F2 to F16 in the cell. All the way to A2 to A16. I should drag it all in the Excel, and Excel, I should bring the sum product in front of it, and the sum product will multiply everything, and then that will be able to do that. So this is a way, it's a formula that I've been, so if I answer the question, what formula is here, you know what formula is there. You know what formula is there because you know it's the total cost. But you know it's a total cost, so you go back to go and check what is the formula for the total cost, and this whole thing is a formula for the total cost. So if that whole thing is a formula, I look for those in the Excel, okay? And then you pick them, and then you can now calculate and then multiply it, okay? And then you can indicate that, oh, it's a matter of multiplying the 16 by that, this by that, this by that. But you talk about the cells because you are talking about formula. You're talking about formula, so you talk about cell. So this is why I say that a person cannot run away from the Excel. You can't run away, oh, I will not do the Excel. I will not learn the Excel. You got to master and learn the Excel. Okay, the next one is what formula was typed in cell I2 to I9. I2 to I9. It is a sum product if. It's a very complex formula, but you need to just understand. I2 to I9. Okay, here. I2 to I9. Now, when you go back, you will know that that is representing the left-hand side of the equation. These ones, the left-hand side of the equation. So you can now use your own approach. Now, how do we normally do that? We just take, there's a number 1, 1, 1 in front of each one of them. Okay. So we are just multiplying each one of these by the decision variables. Okay. By the specific decision variables. Okay. X1, 3. We are multiplying, there's 1 in front of each one of them. So the formula that can be used for this, you can just write your own addition formula using the Excel. Okay, so you have X13 plus X14 plus X15. Now, where is that in the Excel? Okay. X13, X14, X15. Now look here. This is Nebraska, X13, X14, X15. Okay. X13, X14, those are the names for it. So what formula is going to be used for that? So it's this one, okay? So this formula, this one here, plus this one here. So I will say A2 plus A3 plus A4. Okay, so these are the ones that, and according to them, all of this should be equal to, and if you come to the formula here, all of them should be equal to what, 300. Okay, so all of them should be equal to 300. And a 300 would have been a number that you've already written in the Excel because it's the right-hand side of the constant. You would have written it, so that one is not a formula. So that formula here, let me show you. That formula that you see here, it is just A2 plus A3 plus A4. The next one is A5 plus A6 plus A7. Then the next one is just adding them. Okay, just like that. And then you keep going. Because eventually those values will change. That's what we know. Eventually they will change when the objective function values have changed. So you just look at the formulation and then you look at the formula in the Excel. But then this one was a complex one that was indicated some if which I used, to show a bit of complexity. So try these things in Excel. You'll appreciate it better. What is optimal solution to the maize cultivation problem is very simple. Okay, the optimal solution is very there. Okay, you can see them. Transport 300 from Nebraska, to Des Moines. Transport 300 from Colorado to Omaha. Transport 300 from Omaha to Cincinnati. Transport 200 from Des Moines to Chicago. 100 from, it's all there. It's just picking these values. The one that are having no zeros. But if it's zero, you don't have to talk about it. If it's not a zero, that's when you do. So what I just said is here. Transfer 300 from Nebraska to Des Moines, transfer 300 from Colorado to Omaha, okay? And then you just talk about all of the rest. Okay. And then this is the rest. And finally, you know that you have to calculate the total cost. Because now that you know where we are transporting it from, just fit them into the objective function. And then, boom, you have a total cost of 12,400. So this is it. This is how the transportation model works. It works basically, the transshipment model, it works basically just like the transportation model. The only thing is that you include some more nodes. That's all, some more nodes. Okay, at this stage, if you have a question, you let me know.